In this video, we are going to learn the quadratic formula. It is another method to solve quadratic equations. Earlier in the semester, we solved quadratic equations by factoring. But what happens when you cannot factor? Well, we can still solve. There's two such methods we can use: completing the square, which we will learn in another video, and the method we're going to look at right now, the quadratic formula. You can derive the quadratic formula from completing the square on the general quadratic equation of ax squared plus bx plus c equals to 0. The formula that you get is right here, and you have to memorize it. We'll learn how to sing it in class to the tune of Pop Goes the Weasel, but it's a formula you're going to use as long as you are taking math classes. Now, once you memorize the formula, it's very easy to use, and that's what we're going to look at today. So I've written out a process. The first thing we have to make sure is that it is in that standard form, so we can identify a, b, and c. Now notice a is in front of x squared, b is in front of x, and c is what we call the constant. Then we're going to substitute the numbers into the formula and then do some arithmetic. And really, the arithmetic is probably the hardest part. Right, so let's look at this first example. It's in standard form. A is the number in front of x squared. B is the number including the sign in front of x. And C is your constant. So that's pretty easy. Now we have to substitute it into the formula. So x equals, now this says negative b. I want you to think about that as being the opposite of b. So the opposite of negative 4 is positive 4. Then plus or minus the square root, b squared. Now I'm going to go ahead and square negative 4, and when you square something negative, it's positive. Then minus 4 times a times c. I'm not going to do that arithmetic until the next step. Divided by 2 times a. After this, it's just arithmetic. So I have 4 plus or minus the square root of. Now here, this is where you want to count your negatives. You have two negatives, which is going to make a positive. So we're going to have 16 plus 4 times 1 is 4, over, of course, 2. So 4 plus or minus the square root of 20 over 2. So notice I've done the arithmetic under the square root sign. That took a while. Now I have to simplify the square root if possible. And yes, I can. Remember, 20 is 4 times 5, so the square root of 4 is 2. And then the last step, you ask yourself, can I reduce the fraction? And this is where I want you to circle all the numbers outside of the radical, and if those all three can be reduced, then you can reduce the fraction. And since those are all divisible by 2, I'm going to divide by 2. So 2 goes into 4 2 times, 2 goes into 2 one time. You could write the 1, but don't need to, over 1. And since the 1 is in the denominator, again, we don't need to write it. So those are my final answers. Yes, that's two different answers. That says x is 2 plus the square root of 5, and it says x is 2 minus the square root of 5. A quadratic second degree polynomial will have two answers. Let's look at the next example. Again, it's in standard form, so we just need to practice that. So we need to identify a, b, and c. So we're going to have some bigger numbers. All right, I'm going to go ahead and let's say the formula. We have x equals negative b, so the opposite of b, plus or minus the square root of b squared. Wow, I need to know what 18 times 18 is. So I don't have a calculator, so I'm just going to do this. So that's 324. All right, so b squared minus 4ac, all divided by 2a. Right, so we have b squared minus 4ac. Ooh. All right, so I've got to do some more arithmetic. So I have 18 plus or minus the square root of 324. I only have one minus sign, so I know I'm going to subtract. So let's see, 4 times 9 is 36 times 7. So that's 252. All divided by 18. No, 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 do not cross out those 18s. You cannot do that. So we have x equals 18 plus or minus the square root of. So I've got to go 324 minus 252. That's 72. Still cannot reduce. You have to reduce things outside of the radical. Can't touch that 72 yet. So what do we need to do? After we do the arithmetic, we need to simplify that square root. So 72 is 9 times 8, 3 times 3 times 2 times 2 times 2. So I can take out a 3 and take out a 2. So if I take out a 3 and a 2, that becomes 6, and we leave a 2. Now, can you reduce? All the numbers outside of the radical are all divisible by 6. So 6 goes into 18 3 times, 6 goes into 6 1 time, 6 goes into 18 3 times. Those are your two answers. So yes, we had to do a lot of side arithmetic. A calculator would have been helpful, but you can't use that on the test. So just go with a basic arithmetic. Do all the arithmetic, then simplify that square root. Well, what's different about this problem? It's not equal to 0, so we need to put it in standard form first. So I need to subtract 3x and add 2. Well, that looks pretty easy. Man, I wish I could factor it, but it does not factor. There's nothing that multiplies get 13 and adds to get 6. So I need to use the quadratic formula. So we have a, remember that's in front of x squared, b is 6, and c is positive 13. Right, so we have x equals negative b, or the opposite of b, so that's negative 6 plus or minus b squared, so that's 36, minus 4ac, so minus 4 times 1 times 13, all divided by 2a. The more you write that formula, the more you will know it. So we have negative 6 plus or minus the square root of 36. I have one minus sign, so it's going to be minus. 4 times 1 is 4, times 13 is 52 over 2. Keep doing the arithmetic. Again, that's the hardest part about this. Now notice, 36 minus 52, that's a negative number, right? So we have to subtract and take the sign of the larger. That's going to be negative 16 over 2. Now we see why we need to learn complex numbers or imaginary numbers. We can take the square root of negative numbers. The square root of positive 16 is 4, but remember that negative, the square root of negative 1 is defined to be I over 2. Now we're going to all the numbers outside of the radical. Can we reduce those? Yes, we can. They're all divisible by 2. So again, remember those are two different answers, negative 3 plus 2i and negative 3 minus 2i. That plus or minus sign does stand for plus and minus, two different answers. Right, number 4, again not in standard form, so we need to distribute. We need to put it in standard form, so I need to move the 6x and I need to move the 11. So I'd subtract 6x and I'd add the 11. Again, now, could we factor that? I don't think so. So again, here comes that quadratic formula. So we have x equals the opposite of b plus or minus the square root, and then we have b squared minus 4ac. So let's go ahead and square that. That's positive 16 and then multiply those together over 2 times 1. Have one minus sign, so that's going to stay negative. That's 44. Again, 44 is bigger than 16, so this is going to be negative. So we subtract and take the sign of the larger. And you should say, I'm going to have another imaginary number. Yes, you are. Okay, let me get some more room here. Just going to move that over. So I'm going to simplify that square root, so I know it's going to have an I. And then 28 is 4 times 7, so I can take out a 2 and leave a 7. And then all three of those are divisible by 2. I'm just doing this example because I want you to see that we can have negatives under the square root, and you need to make sure you simplify those radicals. All right, this last example, you have a lot of work to do to get it in standard form. So we need to FOIL it out. Set it equal to 0, so I'm going to add 7 to both sides. And then, that does not factor, identify A and B and C, and then put it in your formula. Okay, so just a lot of arithmetic. So here we have two negatives again, so that's going to be plus, and 4 times 3 times 1 is 12. So 100 plus 12 is 112. Again, you cannot reduce that 10 and 6 yet. You have to simplify that square root. 112. Let's see, I know it's 2 times 56. And 56, isn't that 7 times 8? And 8 is 2 times 2 times 2. So what have I got? I got 2, 2, 2, 2, and a 7. 1, 2, 3, yes. So I can take out a 4. Now, can I reduce? Let's circle all those numbers. Those are all divisible by 2. And those are your two answers. Now, every example I've done, I could reduce. That does not necessarily happen. Alright, so again, you've got to memorize this formula correctly. You need to take it step by step. Make sure you know what A, B, and C are. Put the numbers in the formula and carefully do that arithmetic. Again, that's one of the hardest steps, believe it or not. Then simplify the radical, and then maybe you'll be able to reduce that fraction.